Hello everybody, welcome back to another episode of College Algebra Lecture Notes. This time, of course, we're talking about section 2.3. We've just seen everything having to do in section 1.6 with applications of radical equations, and here, or rather radical functions. It's kind of weird to put that first because we haven't even had a chance to talk about what functions are yet. And so that's what we're going to do for this one, talking about what actually is a function and what differentiates a function from just a regular old relation. And before we start talking about those things, we ought to just define at least this term relation, because this is going to be our most broad term, and a function actually is a special type of relation, so we have to define relation first. But what a relation is it's an extremely broad term. Many things are relations. And if you just have a relation, it doesn't really tell you too much, because notice here we're just going to say that any set of ordered pairs is a relation, period. Anytime that you have a set that just has some ordered pairs in there, we can just make up whichever ordered pairs we want to have. And what it means for something to be in this set of ordered pairs over here, maybe we can call this the relation R, capital R. This ordered pair being in there means this particular one, 1, 2, being inside of the relation. It means that 1 is related to 2. We don't know why it's related to 2 because there's not too much about it. You know, this is a very vague type of a relation. And we can make up as many relations as we want, as many relations just by putting in different ordered pairs in there. And so we have that 1 is related to 2, 2 is related to 3, and then 3 is related to 1 again. And so this is a type of a relation. If we want to actually, I will make one called R star, because we can use stars and circles and every kind of thing we want in mathematics. You can make whichever symbols you want. I'm just choosing to use letters from the English alphabet. But what about a relation? And of course this, I understand this is not a class about sets. That would be more like the class Contemporary Math or something. But we can narrow down what we mean by this relation if we actually define what it is. Like if we want to say R star is going to be the set of all things x, y, such that x is equal to y. This would be a thing. And the way that I just pronounce this set out loud is, of course, how you do it. You say like the set R is the set of all x, y, and this one goes such that. There's a couple of ways to put the such that. Some people will put such that, or else some people will put just a vertical bar. It's all the same thing. And so this relation, this would be one that we're familiar with. This is the relation that we use with numbers. That's called equals. This is the relation. This is how they are related. I will say how they are related. So it's possible to specify what the relation is. And it's actually not necessary for these to be numbers. But of course, since this is a math class, we like to talk about numbers. But we could have even a different type of set that maybe is called smiley face set, and it could be just the set that goes smiley with face. Smiley is related to face because when you put them together you get a smiley face, of course. And so, like I said, relations, it's a broad term. It's just talking about sets, and sets are even more broad. And so we will stop talking about relations, except for we have to understand that a function is just a certain type of relation. So there's a definition here for what does it mean a function. It is a relation, first of all. And I would like to mention, by the way, about relations that all of the x values, so basically the ones that just come first, like in our set R, we have, 1, 2, and 3. Those are the x values, as it were, because x comes first in this case. And then the y values, which the y values come second, are the ones like 2, 3, and 1. the set of x values is called the domain, and the set of the y values is called the range. And that's true for all relations, not only for functions, but actually for every type of relation we will use that terminology, domain and range. But what we have is another definition, which is for a function. And a function is a special type of relation where we can use this type of a phrase, y is a function of f, or rather y is a function of x. If we have this case where if you have something in the domain, there's exactly one value of y that corresponds to it in the range. And so, for example, if you have a relation, I'm just going to call it S, and that one goes 1, 2, and it also goes 1, 3. And then we're done with that relation. 1 is going to be related to 2, and also 1 is related to 3. And we're wondering, is S a function? And we want to answer this question. What we need to think about is it true that for each x in the domain, there's exactly one y? And the reason for that, of course, with functions, you want to be able to plug in the x value. So like say, for example, what happens when x is equal to 1? What does y equal? That's what we would want to ask ourselves if it was a function. We'd say, well, what if we plug in 1? What will we get as an answer? But then we see that if we plug in 1, we might get 2 as an answer, or else if we plug in 1, we also might get 3 as an answer. It's not clear what is the corresponding y value. There's too many to choose from. And so we can say, no, it's not a function, because there are too many y values that correspond to the x value of 1. There should only be one y value. And that gets us into this idea of this thing called the vertical line test. Oh, that's a bad line. That's not any type of horizontal or vertical line. It goes vertical line test is the one basically to check, because if you think about what happens when you draw a vertical line, is that every number or every point that's along a vertical line, and it's hard for me to draw a vertical line, but every point that's along this vertical line over here has the same x value. And what we're checking is, for all of these x values, is there ever a case where one x value has more than one corresponding y value? And what you'll see, like for number 1, and we're just understanding about the vertical line test by means of this example, since it crosses this relation, this here is a graph of a relation. And we're wondering, is this graph a graph of a function? And of course it's not, because for this x value, actually for every x value that goes like from -3 up until 3, every x value in between there has 2 corresponding y values. So it is not a function. Not a function. It fails the vertical line test. And so we can see, this one, number 2, it would pass the vertical line test. We can just draw vertical lines along here. It's not going to ever cross that graph more than once. This one, it seems, if you get going with it, it seems like it's doing okay. We're just drawing vertical lines and it's not ever crossing more than once. But then you see actually right along the y-axis, if you draw this vertical line along there, it crosses twice. So that's a big no. This one was a yes. And this one is a no. It crosses twice. There are 2 corresponding y values for the x value of 0. And so that's what we're dealing with functions. We will take a look at some more examples of stuff having to do with functions in the next video. Thanks. Bye.